Good morning, everyone. We welcome you on the fourth day of this workshop. Today, Dr. Amit Kumar, who works at IGCAR, Kalpakkam, as a scientific officer F and as an assistant professor at Homi Bhabha National Institute of Mumbai, will be delivering his lecture. He is an expert in nuclear aerosol science and technology relevant to SFR safety, filtration, science and technology. Dr. Amit Kumar has conferred DAE Group Achievement and Young Scientist Awards in 2017 and 18 for his outstanding contributions to science, engineering, and technology. He is also a member of several professional bodies, including the Indian Aerosol Science and Technology, that is ASTA. Let us give a warm welcome to Dr. Amit Kumar for delivering his lecture on aerosol generators, nanoscale to microscale. Please welcome Dr. Amit.
Yeah, you are going to present my Let's be changed.
Yes, yes. So good morning, all of you, and thank you for introduction. So I am going to present what are the aerosol generator from nano scale to micro scale and application towards the medical, health, science, and industrial application, and how to choose a correct aerosol generator to calibrate the instrument, as well as when do the research for a particular problem, then how we can simulate the exact problem, then what are the aerosol generation method that need to be correctly understood. So to start, so by content of presentation like that, I will some give the introduction, and then what are the type of aerosol, because generator will depends on the type of aerosol, what you want to simulate, or actually what study you want to carry out. And then aerosol generator principles and type of aerosol generator, from atomizer to nebulizer to electrostatic atomizer and evaporation condensation method and vaporization and condensation method. And then factor to be considered for selecting the aerosol generator. And then application of aerosol generator, and then I will conclude my talk. So begin with the introduction. An important element of aerosol technology and science and technology is the aerosol generation. This aerosol generation need to be perfectly carried out for the instrument calibration, conducting aerosol fundamental research to industrial and applied research, and developing and testing of the air cleaning system like filtration, HEPA filter and other things, and then air sampling equipment. So monodisperse test aerosol also need to be understand like size, what is the size, and shape, whether it is spherical or non-spherical, and their density, whether density is deviating from the material density. If there is a agglomerated particle, so of course density will decrease from the material density. And then test made with the series of monodisperse aerosol, each having different particle size, and permit the evaluation of the effect of particle size and performance of the instrument. Then polydisperse aerosol used for calibration and some equipment in controlled laboratory, and also polydisperse aerosol, whatever the naturally generated aerosol, it will be basically polydisperse because of many phenomena. So characteristics of ideal aerosol generator are constant throughput and reproducible in each time, and stable and uncharged, because many generation process in generating itself some charge associated with the generation method. So that need to be easily understood. So let us, before going to the generation method, we should know the what are the aerosol. So type of aerosol basically we call as a monodisperse or polydisperse. So monodisperse meaning कि if geometric standard deviation, if it is a less than 1.2 or sometime 1.3, we call as a monodispersion. Means dispersivity will be less. And polydisperse aerosol have the dispersivity more than 1.2 or sometime it will be 2 to 3 also. If it is a few order distribution is changing. So some examples of monodisperse aerosol in a natural occurring aerosol and man-made. So like a pollen grain, they are naturally, but they are mostly maybe if it is a particular pollen, it will be having the similar size, maybe narrow distribution. Then sea salt aerosol, when it is emitting from the sea surface, it will be having mostly monodisperse. And then smoke from the controlled combustion, where we can avoid agglomeration, then it will be having the narrow size distribution. And then man-made aerosol produced by inkjet printers and aerosol produced by laser affiliation or plasma touch method and nebulizer. They are the basically man-made. Then what are the examples? Solid aerosol and liquid aerosol. Monodisperse can be both. Means aerosol definition itself tells solid or liquid particles suspended in a gas medium. So latex like PSL particle and glass beds, microspheres, they are the solid particle is in some colloidal form of the some solution. And metal particle, where we need to be generate like metal, like generally in like cuttings, in metal sheet cuttings and metal welding, this metal aerosol will generate. Then liquid aerosol like IL droplets and sea salt like NaCl and PaO aerosol, these are the liquid aerosol. So some examples of polydisperse aerosol in naturally like atmospheric aerosol, they have from Aitken mode to the coarse mode. So they are the polydisperse. And then pollutants, which is emitting from the various industrial influence. Then fog and cloud are mist. They are also polydispersed. Then man-made like industrial emission, vehicle exhaust and aerosol spray, like paint technology, or it is like agriculture field where we are spraying the pesticides or some coatings to the agriculture field. So some examples like atmospheric dust and combustion smoke are the solid particles. And if it is a hygroscopic nature of combustion, then sometimes it will be the both phase, solid and liquid phase. And liquid aerosol like aerosol spray, and here also fluorescence and PSL. Fluorescence aerosol generally used for track the movement of particle or indoor dispersion or something. So to begin the aerosol generator is a device which creates airborne particle which is suspended in a gaseous medium. So aerosol generators are used in many applications, from the industry to laboratory to research to the dispersing measure and transport and dispersion also in open atmosphere. So aerosol generator can be broadly classified in two ways: monodisperse aerosol and polydisperse aerosol generation. So broad category here define aerosol generator, but it is not limited to up to these whatever the listed here: atomizer, nebulizer, and electrostatic spray, thermal generator, chemical conversion. Chemical generation also generate aerosol, where like gas to particle conversion or some chemical reaction like combustion, and colloidal aerosol. So atomizer are the device that break down the liquid to fine droplets by various mechanical forces, whether it is a pneumatic way or it is ultrasonic way or some or electrostatic way. If we atomize some liquid, so that is called atomizer. And let us principle will be, our force will be different. And this application already I explained is spray, painting, pesticide application, medical nebulizer, and industrial application like that. So type of atomizer like pressure atomizer, where we generate aerosol by high pressure air jet, where the this liquid film can break in fine droplets. And these are the jet atomizer and swirl atomizer. Swirl atomizer, nothing but the air, your jet will be in rotating, rotational, so that it will create the fine particles. Then pneumatic atomizer like pressure based or fluid atomizer are too fluid. If the atomizer has need to be generate some multiple aerosol, multiple substance aerosol, then we can use some multiple fluid to atomize. So two element aerosol also sometime need to be generated. When we mix behavior need to be studied. So the principle is same, means air we need to be feed in a high pressure to the water film, so it will be break and generate the aerosol. Then ultrasonic way also we can create aerosol. Here we can liquid, we can ultrasonicate in a high frequency, so it will create some droplets and generate the aerosol. Then electrostatic atomizer. Here also drop when emptying the very fine nozzles, and you apply the electrostatics high potential, then this droplet will break and disperse, because the particle are the homogeneously unipolar charge, so they will disperse in away each other. So in this way it will be dispersed in the electrostatic generator. And corona discharge is basically for some charging the aerosol or neutralizing the aerosol very used. So this is the atomizer generation picture, where we can use the various type of particle like PSL suspended in some solution. It is like colloidal, and salt NaCl or KCl we can use, and then DOP and PAO aerosol, all are the liquid aerosol, so that it can be atomized by this atomizer and it can generate the aerosol, whatever the application. So here the principle is same. The liquid, whatever the solution containing the particle, or it is a solution, it will be transported to the nozzle by Bernoulli effect, because when you high speed flow is there, some vacuum will create. So this flow, the liquid will go, and it will release to the nozzle where your high velocity pressure air is flowing. So it will create spray droplets. So here just one example I am showing. So we have 1.3 micrometer polystyrene latex particle which has been atomized by this atomizer, and we have put 1.6 to 100 ratio this PSL particle in a DM water, and then we atomize, and we have put a heating and condensing copper tube where your water can evaporate and condense. Only PSL particle can go the calibration chamber. Then when we measure by OPC, we found that our generated particle, our standard test particle is 1.3 micrometer, and the generated measured particle by optical particle counter is 1.25, and sigma is 1.2. So it will be meeting the monodisperse aerosol property. Sigma is less than 1.2, and also your variation between the standard test aerosol and generated aerosol is less than 4%. Then nebulizer, basically nebulizer is also one kind of atomizer. Here the large depth, same way it is generated, but it has slightly different meaning, because nebulization can be carried out by piezoelectric nebulization, cavitation. When you create cavitation inside the fluid, then it will create some bubbles and generate the droplets. And then pulse nebulizer also there, and wave by ultrasonic signal or ultrasonic wave also we can create. So we can create nebulization by various methods. So principle, the generation principle will be the same, but the creation of nebulization will be by different methods. So one typical examples of aerosol nebulization is given here. If you see the compressed air of pressure of 35 to 340 kilopascal. In this range we apply in the nozzle, so that air stream can be break a fine droplets and large droplets. So we have some curvature so that large droplets should not go to the calibration chamber or the where we want to study. So it will fall back. Only small droplets, small particle will only release to the nozzle. And here we can achieve very high concentration, even though we can achieve 10 power 12 to 10 power 13 per meter cube, or we can tell 10 power 5 to 10 power 6 per centimeter cube. And concentration also we can reach 5 to 50 gram per meter cube. And then particle size ranges from, sometimes it will be some micron, also maybe 500 nanometer, but mostly it will be in 1 micrometer to 10 micrometer. Then this is the example of Leskin nebulizer aerosol generator. Here also we can use various type of fluid like PAO or DOP, liquid paraffin, and mineral oil also can be used for generation of aerosol. And here the material whatever dissolve in a fluid or solution, and the diameter whatever emitted by the nebulizer can be correlated based on the diameter of generated and the what is the ratio of the material dissolved in a solution. Like if diameter is emitted is some x diameter like d, and then aerosol whatever generated dp is the multiplication of the your material ratio whatever available in a solution. Like NaCl, if it is 5% and then 95% is water, then this ratio will be the 5%, means 0.5, 0.05. So in this way we can create whatever the generated aerosol with the size. And then we have other aerosol generator like vibrating office aerosol generator. It is also one kind of atomizer where you can take the liquid from here to the up to this portion and generate this mesh is there, fine mesh. It is vibrating in an axial direction. So whatever water film is reaching to the mesh, it will break and generate the aerosol. And this diameter of aerosol can be calculated with this correlation, where the QL is the flow rate of the liquid and F is the frequency of vibration, mesh vibration. And here also we can achieve not such a high concentration whatever previous generator can achieve, but yes, it is quite high to test the instrument. Then here the particle size is in micron size, 15 to 100 micron. Then this is the typical size distribution. If you see, it ranges from nanometer to micrometer, even though 8 to 10 micrometer also can be achieved. And then another generator is electrostatic atomizer. Here, as I told you, there is a high potential field applied in the tip of the generator where the liquid droplet is coming, and this droplet will, when droplet is coming and it will be bursting, then it has the uniform charge, and this charge, because of uniform charge, each particle will repel each other, then it will be homogeneously distributed. And this type of aerosol generator is very famous in recently COVID pandemic time to decontaminate the surface, because when conventional spray you use, whatever surface is visible to the sprayer, that only contaminated. But this electrostatic sprayer can go which surface is not seen to the direction of spray, even though it can go other part which is not easily accessible to the sprayer. So such type of this decontamination spray or this spray electrostatic atomizer is very useful in recent COVID pandemic time. And then now in agriculture, to put the pesticide in a large area of agricultural land, such type of atomizer is used, because once you spraying from the top, it may not go to the bottom side of the any surface in conventional atomizer, but in this will deposit in even the bottom side of the leaf or fruit. So it will be like homogeneous deposition of this aerosol particle. So this is very famous in the agriculture and this health. So the principle is same, this atomizer, and here particle can be from some micron to micron. D50 around maybe 10 micrometer or like that. Then one example here I want to show, in an apple, the coating is carried out by conventional atomizer and then this electrostatic atomizer. If you see, the first apple it has coated by conventional atomizer and second apple has coated by this electrostatic atomizer. If you see, it is a homogeneous coating is there in all direction, but in that only one direction is coating is there. Then for the industrial purpose, we cannot use this conventional whatever atomizer or generator is available. We need to be design a aerosol generator for particular application and particular industry. So we are working like nuclear industry. So we have aerosol generation method is different. Like our generation method is this vaporization, metal vaporization and condensation method. So these conventional atomizer will not work for R&D purpose and other application. So we have a plasma torch aerosol generator. This generator is different from the other generator and it can generate any metallic or ceramic metals aerosol. And then environment, if it is inert, then it will be pure metal aerosol. If it is environment is like atmosphere, then it will be oxide aerosol or some other chemical. It depends on the what metal you are using for the generation. And then this will be the best simulate for our accident scenario in a nuclear reactor, because of the temperature of plasma. It will be maybe 5,000 to 10,000 degree or Kelvin or degree centigrade. So it will also give continuous source for a long period of time and also generate very high concentration. Sometimes it will reach 10 power 8 to 10 power 7 particle per centimeter cube. So this plasma torch is made of various small system called like power supply, high voltage power supply, then torch body. This torch body is here and this power supply is here, and then powder means what powder we are feeding, that powder feeder. And then other because this plasma will generate huge energy, so we need to be cool the electrode, anode and cathode, otherwise electrode anode melt and this will very fast will be erosion will be there. And then other gas distribution line, what gas we are using for creating the plasma, whether argon, helium or nitrogen. So that gas distribution things. And then of course aerosol chamber, where we pump these aerosol, and then we can study the time evolution of aerosol and physicochemical property of aerosol. The generation method of aerosol is evaporation, then nucleation and condensation. And then if it is concentration of particle more than 10 power 5 or 6, then agglomeration will take place. Then this is plasma torch body, which is made of the cathode and electrode, and they are inserted in a this conical anode, and the distance between the anode and cathode will be as minimum, so that this plasma spark can take place. So these are the typical properties and specification of the plasma torch. It has the capacity of 25 kilowatt, and the arc current is ranging from 100 to 250 amperes, and potential is around 50 to 100 volt. Then it can work up to 5 to 20 kilowatt. And then we have characterized these aerosol, these plasma torch, the generation characteristics. So once we increase the applied current to the plasma torch, then our power will increase. And if we increase gas also, then also this power will increase. So we need to be operate in a very reasonable this power, because when we operate in a low power, it may flicker. Plasma flame may be flicker, so complete evaporation may not happen. And then we need to be operate where our flame length as well as flickering should be less in a plasma flame. And then the efficiency of the plasma torch, because to cool the plasma body we using this DM water, so some energy, whatever input energy we are giving, some energy can be carried out by this cooling water. So as power increase, then efficiency of plasma torch will decrease. So I just want to show the video how it will be plasma flame which injecting from the plasma torch. If you see, this is the nozzle of the plasma torch, and this is the plasma flame. This flame temperature inside may be 5,000 to 7,000 or sometimes 10,000 degrees centigrade. Any powder you feed from here, it will simply become the gas phase, means vapor. And once this vapor will move in a downward distance or away from the plasma zone, because of huge temperature gradients, this vapor will nucleus and condense and then form the particulates. And then this generated strontium aerosol, we have fed the strontium powder, and generated aerosol we have characterized by SMPS. If you see, the first source of particle is around 20 to 30 nanometer. Because of high concentration, immediately it has agglomerated and the size distribution has changed. And we stop in a 2 to 3 minute plasma torch. So only initial generated particle only capture in the first scan. Then these are the agglomerated particle. As time progress, this size distribution also becoming the monomodal to monodisperse to polydisperse, and your sigma also increasing. If you see here, this count median diameter or mobility median diameter is around 25 nanometer, and the sigma is around 1.4 or 1.45. Then as time progress, this MMD is increasing, because this is the source time. So during source time, huge growth rate is there. And then after stop, there is a marginal growth rate is there, because smaller particle is vanishing and larger particles are appearing because of agglomeration. And then concentration we can achieve 10 power 7 particle. The peak concentration are 10 power 6 into 10 power 6. And if you see over a period of 1 hour, the concentration only has decreased 6 times, even though order is remains same. Then our other type of reactor where the liquid coolant or liquid sodium is used as a coolant. So that aerosol, how to generate in a laboratory? So we have a combustion chamber. This combustion chamber, here we put a 5 to 10 gram of solid sodium in an argon environment. This chamber will be maintained in argon environment, and then we heat it by heater, so that this whatever solid sodium can melt, because sodium temperature, melting temperature will be 98 degrees centigrade. So in 98 degrees centigrade it will be start melting. Then we increase this temperature up to 500 degrees centigrade, because our objective to generate aerosol at 500 degrees centigrade. Then argon, whatever inert environment is there, we will let out from the one wall. Then atmospheric air, once we purge in this combustion cell, then sodium and oxygen reaction start. So this aerosol, sodium oxygen reaction is an exothermic reaction. Then we liberate the heat. Then this reaction will be faster, and then aerosol will be generated by here chemical reaction, sodium, moisture, this oxygen. and then we open the gate valve and pump the aerosol in a aerosol chamber. And then we have characterized this aerosol size distribution initial. This is means first minute, whatever aerosol has generated for three different humidity, what we maintain in the aerosol chamber. Then as humidity increase, your median diameter also increase, because these aerosol are hygroscopic. They have affinity to absorb moisture. So higher humidity, more moisture is there, then the particle will be in a, like it is like a liquid drop, liquid drop suspended in a gas. While in a 20% RH, it will be mostly solid. Then also we have a bigger chamber where we create a bigger pool type of fire. Means 0.5 meter, 0.5 meter, this tray is there. Here we can, liquid sodium we can heat here and we can drain here. As soon as liquid sodium will drain here, it will catch the fire, because this chamber is in atmosphere. Then it will generate aerosol. So generation of aerosol is captured. If you see the draining, in draining we have completed it within 30 seconds or 25 seconds. And then as soon as drain has completed, this is smoke is generated. And in 600 seconds, around maybe we can tell 10-minute time, your visibility or 15-minute time visibility has completely stopped. So concentration inside the chamber has increased maybe more than 1 gram per meter cube. Though the fire is continue, it will take some 20 to 25 minutes, sometime half an hour to quench the fire. So just here I want to convey one, just I want to show the video how the fire, sodium fire will take place. This fire is different than the other hydrocarbon or conventional fire. This height or length of the flame, it will be hardly few centimeter, maybe 10 centimeter or like that. But your petroleum fire or kerosene fire will be in meters. But liberated in because vapor pressure, sodium having vapor pressure of less than the hydrocarbon or kerosene or the other petroleum fire. So by this method, whatever aerosol generated, they are ranging some 3 order or 4 order size distribution. Where your combustion is taking place, the particle size will be less than 100 nanometer. But when this flame is away 1 meter or 2 meter, the size will grow and become 1 micron and above. And then after half an hour or 1 hour, it may be 20 micron or sometimes 50 micron. So any aerosol instrument, conventional instrument, whatever we are using, either SMPS, ELPI or OPC, cannot handle such a high concentration or such a wide distribution. So somehow we have a laser diffraction based instrument where we can collect these particles in a non-dissolving media and we analyze. Here we can analyze from 10 nanometer to 2 millimeter, 2000 micrometer. So that technique only can applicable. We try to use it with dilution OPC, but it is stopped in within 9 minutes because it is saturated. Concentration has exceeded its limit. And by theoretical simulation, we found that the size distribution are 10 nanometer to 80 micrometer. So for to deal with such a high wide distribution, we have only one instrument, mass excision. So mixed aerosol, we also have generating by both way. Here we can connect the plasma torch, and here we can create the food fire or any liquid fire. So if we want to generate two type of aerosol in the same chamber and study the mix behavior, chemical, physical property, then we can generate both generation method we can use. This is the typical torch picture, and this is the tray of the full fire. And when our application change, like we want to study atmospheric dispersion of aerosol, then this chamber related experiment generation will not work. Then we have also created a facility where we can create a fire and release aerosol at 10 meter or 20 meter height from the ground and study up to 700 meter or 1 kilometer long a distance what is the physical property and chemical property, or what is the ground deposition and concentration. And in one typical experiment, we found that your concentration is not it is a decreasing or increasing. It is first increasing, and it is a peak in a 100-meter distance from the release point, and then it is a decay. So this type of study generally we are used to validate the dispersion model, like short range dispersion model. So for the lab, to study the lab to the atmosphere, each time we too should have think that the different aerosol generation method, because whatever is standard in market available, that will be not useful for our application. So we need to be self-design based on our requirement and do the work. Then yes, one more this aerosol generator is there. This is for the nano aerosol generator from again vaporization or evaporation and condensation method. Here we can tune the size, or we can get the size as low as maybe 10 nanometer, even though maybe aerosol size is lesser than 10 nanometer also, but because of the maybe instrumentation or where we are measuring, because sometimes aerosol generating in some location and we are measuring some other location. So whatever generated aerosol will grow because of various phenomena, vapor condensation or nucleation. So in this method we can achieve very high concentration as well as low size uh, aerosol. So here basically the hard wire, this wire, metal wire subjected to high potential, so that it will, because of high potential, it will create very high temperature, maybe 2000 degrees centigrade or something. Then this metal will, metal wire will be evaporated. Then this vapor will nucleate and condense and form the particulates. This is the basic principle of this generator. And if you see, the generated aerosol will also depends the potential whatever applied across the wire, or temperature, because temperature and potential is directly related, directly proportional to. And then the what flow rate inside the generator you are maintaining, means what dilution, whether you are diluting slow or fast. If you are diluting slow, then your concentration will increase. If you are diluting fast, your concentration will reduce, and size also may have the smaller size. Then here typical measured size is around 10 nanometer, and this here two wires has been used different metals, and both metallic wire is giving almost 10 to 20 nanometer aerosol, 10 to 15 nanometer aerosol generated. Then in these are the aerosol generation method I have covered, but it is not all the generator I have covered. But okay, just I want to give some feelings. What are the conventional or market available aerosol, and what nuclear industry or other industry is using for generation of aerosol. So nano scale and micro scale, aerosol generator we can characterize based on the what principle it is generating aerosol. Like if it is a gas to particle conversion, chemical reaction or vaporization and condensation, definitely these particles are in nanometer range. If any like sprayer or nebulizer or any atomizer, they will be having some micron or micron particle. And powder dispersion or fluidized bed aerosol generator, some other aerosol generator, they have the larger diameter aerosol. So based on that, you may now understood which principle they are generating. So aerosol size will depends on the fundamental principle how they are generated. Then application, as I told you, application of aerosol generation is a wide, not limited to these whatever listed here. Environment science like air pollution research or monitoring, continuous monitoring, climate modeling, and particle and research like nanoparticle synthesis, or some particle to generate for the enhance the lubrication or enhance the other maybe the shielding property or other property, various property. Nano aerosol or nanoparticle is very wide research topic, and people are using from paint technology to the spray technology. In any industry, you think nano aerosol or nanoparticle are researched. Then drug delivery, respiratory therapy, and medical, like drug delivery and pharmaceutical, what type of aerosol should be uh, give to the patient so that it will be do the fast work in the patient. And then industrial, like pesticides application, agriculture, like where the coating or preserving of the fruit for longer period of times. So that application. So here last I want to convey the what factor you need to be considered when you are choosing the aerosol generator. Because first you know your problem, what problem you are attempting. So best suit that problem means what research you want to do. So the best generator what is suiting for that research objective means generation method, and as much as possible you generate similar type of aerosol. Then only maybe the whatever code validation or model validation will be useful, because the aerosol fundamental or modeling or phenomena will depends both physical and chemical, because chemical nature of aerosol also depends maybe charging also, because chemical nature of aerosol is differ, then maybe associated charge, elementary charge associated of the particle is will differ. So you need to be choose the right aerosol generator for the right application. Then what particle concentration you are targeting, and then whether you want to solid aerosol or liquid aerosol. Then what is the source rate? And source rate means what is the generation rate? Whether it is a constant, you need to be constant aerosol, or you need to be have some lower flow rate and higher flow rate. And then cost and maintenance, because we can procure the generator, but after maintaining, some aerosol generator has very huge cost to maintain, like plasma torch. It is a costly, but it's maintained to working. It also requires a lot of money. Then the key consideration of aerosol generator, like performance, it should work not 1 or 2 times. It should work in a month or year to give the your serve the your purpose. Then reliability and use safety. Of course, it should not release some aerosol to the chamber where you are doing experiment, because any aerosol it will be generated aerosol, it will be, though they are telling it is health, not health hazardous, but it will be harmful. So you need to be choose safety also. Then maybe review of the your peer or colleagues what they are using in other lab, that will also guide you to selecting the generator. Then last summary and conclusion. So aerosol generator are a versatile tool with application of a various field, from industry to health to agriculture to the research. And understanding the different type of aerosol generator, there is specific application, research and professionals can select more suitable device. So based on this, you may now understood what are the mono natural and mono man-made aerosol, and what are the mono dispersion polydisperse aerosol generator, and their generation principle, whether it is evaporation or condensation method, or it is a chemical reaction, or it is atomizer or nebulizer or electrostatic principle. So these, and what are the typical method we use in nuclear industry to generate aerosol or simulate the accident condition or to do research. So these few questions are answer you may know if someone is asked. So at last I want to show one same picture, whatever this strontium aerosol generated by plasma torch. If you see, these aerosol are the very fine aerosol, maybe less than 1 micron, but they have affinity to agglomerate or aggregate it in one place. So if you see in this picture a lot of aerosol, and they are like some square and spherical nature. So in it is for a strontium case. If you choose other material, it may have chain like structure or some other structure. So each metal have different. When you generate nanoparticle, it will agglomerate in a different way. So with that, I want to thank you everyone for your kind attention. Thank you. So no question, then okay. Yes. You speak like that. Your voice is coming, you can speak. Yes. In plasma charge, two, three parameter is important. One is it is a high voltage and high current, like high potential charge. So first is electrical safety is very much required. So your wiring, everything is very crucial to reach. Where the plasma torch is there, everything is insulation should be there. And whoever taking the initiation of the plasma torch, he should aware of the each part. So one is electrical safety. Second, because it is a high temperature. So you should design a chamber such that your operation duration of plasma torch should be optimized. Because if your chamber is 1 meter cube, if you operate 5 minutes, your temperature may go more than 100 degrees centigrade. So your O-ring and everything will fail to 100 degrees centigrade. So aerosol will leak out. If you have bigger chamber, you can operate a half an hour, 20 minutes. So temperature. So always you monitor the temperature of the chamber as well as the aerosol chamber where the plasma flame is there. One second is a temperature, because it is a temperature is very high. Third is a gas. Because if atmosphere is there, it can create ozone or some like nitrogen is there. If we are using atmospheric air, so this NOx or this can be generated. So this gas inhalation also. So your chamber should be perfectly leak tight. When you are sampling the aerosol, so these are metallic aerosol, again they are health hazardous. So your sampling, whatever instrument you are sampling, then after your instrument, it should be zero filter. And it is proper where you are doing sampling. So their room will be well ventilated, and all system after instrument should be the zero filter. So these are the few health I can recommend. So these are the precautions we need to be take care.
Thank you, sir.
Yes. Yes.
Sir, in electrostatic and atomizer, you told that the aerosols will be equally distributed backside. But how does that happen? Is there anything special? Or
Yes.
why?
So these are the whatever the fine aerosol generated, they are having unipolar charge, either negative or positive. So any surface, if you want to do deposit, so it will create a image forces and it will attract by the surface. Like some chair is there, it has some static charge, and this aerosol is coming, they have also charge. So they will, even though if opposite polarity is there, then of course the attraction will be there. Though the polarity is same, they will create an image charge in the surface, so that backside also it can go. Because other conventional, it is like impaction you are depositing, like spray. You are doing in a surface, so it is like impaction spray coating is doing. But here your particle will go in the other side and it will be attracted and deposited because of this charge. Yes. Okay.
Thank you, sir, for informative lecture. Now, our second guest needs no introduction. He has made an inedible mark in the field of aerosol characterization. Professor Neeraj Rastogi from PRL Ahmedabad is the Vice President of ISTA. He is the member of Editorial Advisory Board, Asian Journal of Atmospheric Environment. He is the nodal faculty for Gujarat, the National NCAP, National Clean Air Program, Ministry of Environment, Forest and Climate Change. Currently, he is working as professor in PRL Ahmedabad. His research area is to understand how sources and processes affect aerosol concentration, composition, and characteristics over different regions of India and the surrounding oceans using offline and online measurements, and how the atmospheric processes of aerosols affects their implications of atmospheric chemistry, air quality, health, human health, aquatic ecosystems, and climate change. I invite Professor Neeraj Rastogi to deliver his talk.
You can see the screen is before. Huh? We go location. Are we
Yeah, otherwise we can keep on that side also.
Yeah.
So am I audible? Okay. Am I audible? So good morning everyone. So before I start, may I request people sitting behind come in front?
Sir. Excuse me.
Please.
Sir.
And let me tell Miss, I'm going to share something. This will not be like a lecture, it will be more like an interaction. So I'll be telling few things and then I'll be asking you. You have to be attentive. Anybody's number can come anytime. So once you are saying that you understood, I may ask, then you figure. That is why board is here. Okay? So as you can see, my name is Neeraj Rastogi and I work at PR.
Sir. Online visible.
That I want to use to like this. Yes. Okay. So as you can see from the title, what we are going to talk about, we'll be talking about aerosol chemical composition. And second part is more important, intricacies of measurement. See, this is instrumentation workshop. We are learning about instruments, but many of the things you can find out on YouTube or just you will Google and you will find many things. But these intricacies you will not find anywhere. It comes with experience, and that is what I want to share with you. Whatever I have done over last 25 years in aerosol chemistry particularly. So before I start, let me know my audience. So how many of you are PhD students? Okay. Postdocs? Okay. Early career scientist? Then what remains means PhD students are limited. Then is who's the other type? Master. Okay. PhD and master. Let me ask PhD and master. Then there will be more end. PhD and masters. Okay. So whenever I give any such talk, my target audience is you. First, I want to share something, whatever I have done over many years. If I can tell you in short time, then you will start from there and you can further grow. Unlike if you are also learning, you will spending the same time in getting that much knowledge. So be interactive. I will be asking the question, but you also ask. You can stop anytime. Okay. So before we start, very simple question. What do you understand by aerosol? Definition of aerosol. Very basic question. One. liquid and solid particles suspended in the air. Aerosol. This is polymer solution. Aerosol is a polymer solution where suspension medium is air and suspended phase is liquid or solid particles. Okay. What is the size range of aerosols? Size range? 2 nanometer to micrometer. Any number you want to put? 1 nanometer to 100 micrometer. Okay. Why not less than 1 nanometer or more than 100 micrometer? What is stopping? You can not go less than 1 or you can't go more than 100.
Less than 1 good photo. Yes.
Brilliant. So let us see what we have in that one. See the color coding also. And see the size range. Okay. It has a polymer star. Okay, nice. So what the size range we see? 10 power minus 10 meter to 10 power minus 1 meter, which is 100 picometer to 10 centimeter. And there is some color coding. So I like this figure from this paper, so I use whenever I am doing this kind of presentation. So what you see, 9 orders of magnitude things are present in the atmosphere. And there is some color coding. What is that? Whatever things you see in blue, this is rain, snow, bubble, hail, they go in such a big size range. And then you have this gray. Less than 1 is molecule itself. So molecules, when they come together, whatever way they form, then they make liquid or solid or remaining gas. So that is like less than 1 nanometer, whatever I was talking about, is the reason, because you are in this gas. Now again you see there is some color coding. Something is in green, something is in red. What is in green? Bioresorbers. So they are protein, viruses, bacteria, spores, pollen. Bioresorbers. They are all in green. And then you have these things in red. From 1 nanometer to 100 micrometer. And here also you see certain things are written at certain size. In this side, which is force. We can also define this in ultrafine, fine, and force. Ultrafine means 100 to 100 nanometer to 1 nanometer to 100 nanometer. From 100 to 1 it is fine, and more than 1 or 2 we call it force. And you see, whatever I was saying, certain type of aerosols are shown at certain place. Why? Why dust is not at lower side? Sulfate can be on the side, which we will be discussing. And so usually when this is formed, it is not at that side, but it can be. Can anybody tell that why you are these things are at the side only? So the rule है कि metal dust है तो it has to be on force mode only. So it is the way they are generated. So things which are mechanically produced, they are in force mode. Because lower size also they will be in few microns. But if things are forming from gas molecule size is 100 picometer. Things are coming together, forming few nanometer, then further growing. So when things are forming, they are at this side, from gas to particle. When they are directly getting generated from the source, they are on this side. So mineral dust, we know this is windblown mineral dust, and sea salts. How sea salts are produced? What happens? When wave overturns, it traps the air. This air forms bubble. These bubble burst. So whatever you have in seawater, same thing comes in the form of aerosol. So my previous speaker, he was talking about aerosol generation. That is aerosol generation by nature. and you are getting usually bigger size. Sometimes you have fine sea salt also. Okay. Okay. Now what is TSP? Total suspended particulate. This is the full form. What it means here? Huh? Everything that is there in that form. That is total suspended particulate. What is PM10?
हाँ बोलो ना.
Particulate matter less than 10 micrometer in aerodynamic time. Now, what is aerodynamic time? Why it is different than the actual time?
Because every particle are not spherical. So we assume that a spherical particle of that diameter it shall have the same property as that particle.
Is the shape only or settling velocity? Anything else? Density. So you take care of density and shape, and then you convert into aerodynamic diameter. So usually it is about 1.44 times higher if you presume 2 gram per centimeter cube density and spherical shape. Otherwise, it can be slightly different. Then when we say we have 10 to 2.5, what does that mean? So that means we are talking about particular size range between 2.5 to 10. And then size centigrade means if we are putting different things like PM1 to 2.5 and like that. Okay? Good. Difference between primary and secondary also. Primary and secondary. I want everybody to get there. Difference between primary and secondary aerosols. One person. What is it? Volume. Okay. Yes. They are made from primary. What's the word one? Okay. Primary. So particles which are coming as a particle in the atmosphere, they are primary. And whatever is forming in the atmosphere, they are secondary. Okay. So that means they are secondary and they are primary because they are getting directly generated. Huh? Usually I don't speak much. So whenever I am speaking continuously, my throat is fast. Okay. Then what is the resistance time of aerosol? The resistance time of aerosol in that conflict, obviously. Huh? Depend upon environmental condition, atmosphere. It depends on size, density. So atmospheric aerosol when we are talking about, I give a speaker by saying that it is called a dispersion. You consider it as called dispersion aerosol. What is the resistance time? Typical resistance time of aerosol. Few seconds. Few seconds or few minutes. Typically it is considered about a week. But that is in lower troposphere. If somehow, say volcanic eruption, if somehow you can inject something up to stratosphere, then what is the result time? Years, order of years, right? Why it is 1 week in lower troposphere and 1 or 2 years there?
It's also very stable.
Stable. Means lower atmosphere is not stable. Less than time is what? It is the balance between supply and removal. If you are continuous, what is the major way of removal from the atmosphere? Rain. Rain is 80% given by rain. So if you have rain, it will remove aerosol. But that is consequence, it is within troposphere. The certified aerosol doesn't come by rain. Then how they are coming down? They should remain forever. Why? 1 or 2 years only. For 1 year. I have a microphone. You have reckoned that. You have reckoned that thing is nearly right. It is through circulation. Because there is a circulation time for each hemisphere, also between the hemisphere, height by there is circulation time. So air circulate within this time period and they come by circulation. And once they are coming back in the atmosphere, they get removed. So resistance time depends upon the particle size. The smaller the particle, less or more will be the resistance time. Yeah, you have to sum take equal to. The smaller the particle, less or high, what will be the resistance time? Higher. Why? Because now resistance time again, if we are not coming by rain, there are different forces acting on it, right? Gravity is trying to pull, drag force is pulling it. Bigger particle, gravity is more, will come fast. So depending on size, resistance time will change. Okay? Then this is the typical composition. I have plotted, I put some number in Excel and plotted. What we see here, we have dust, we have organics, we have light carbon, we have secondary inorganic. Secondary inorganic means sulfate, nitrate, ammonium, this kind of. Then we have sea salts and we have dust. But this will be the composition. In some percentage will change, but this will be the composition. Now at a given site, do you expect the composition same or it will be different? Different, obviously different. So what are the factors which will decide the composition of aerosol? I listed a few. So obviously composition varying time and space, you know what it means. Even within the day, say we are here in IITM, if you go and measure the atmosphere, daytime in the morning concentration will be different, afternoon will be different, night will be different. So it changes with time, and if you go from place to place, it will be different. And what decides that? Obviously, first is the dominant source. What are the sources you have in the surrounding? Then size of the particle, composition and size. They are related. Now I will be asking someone to come. So let me just. So if we have TSP, if we are collecting TSP here, okay. Over IITM, we are collecting TSP. We have high volume air sample and we are collecting that. And we are going to get the composition. So what is the composition you expect? Majority will be what? Or it will depend upon the nearby sources. Think about it. You are here for a week at least. You have seen what kind of sources here. So what do you expect? Organics. It will be dominated by organics. We are talking about TSP. So I am giving some numbers also. So in that, whatever filter we have collected, it has 1 lakh particle of 10 millimeter, 1 lakh. Then about 1000 particle of 1 micron. And about 10 particle of this size. Now what will the composition? I give you some number please. What is the number now composition will be, now consider this whatever is written there. So if you expect the composition of by ultra fine, you can say this will be dominant, or in this it will be, you can say maybe ammonium sulfate of it. And if you expect this here, you can say mineral dust or sea salt will be dominant. Mineral dust will be dominant. Even though there are 10 particles, that is 1 lakh particles. Why is it so? Size. Size and
The size contribution of PSP, overall contribution of that would be higher even though it's 10 particles.
so now someone can do this on the board. Just calculate the mass. Can someone? Do you want to volunteer or you want me to select? Anyone? Anyone wants to volunteer? So you will calculate mass of 100 micron particle and mass of, for the same mass, how many 1 micron particle will be there? Can you calculate that? Say I have 100 micron particle, some mass. Density and presuming same. Now for the same mass, how many 1 micron particle will be there? Can you calculate it? Use the font respect to your. So first calculate mass of 100 micron kind of particle. You don't have to fully calculate, you can just put some this M something. I said same density. So density you can consider D. Or ठीक है, रो, let it be रो, it's okay. Mass is equal to volume into density. Volume you can calculate using presuming spherical particle, you can calculate the volume of that particle. Let me this mass. Now, same mass, 1 micron particle. So we have to calculate number. So mass you already know. Number. Now if you just have to equate them, right? So he calculated 10 power 6, 1 million, 10 lakh. एक particle 100 micron the as same mass as 1 million, यानी कि 10 lakh particle of 1 micron. So this you should also keep in mind whenever you are collecting aerosol, moving around. If you are contaminated your sample by any chance, how you can affect the composition? Because mass will be coming from. Thank you. Mass will be coming from bigger particle. Okay. Okay. No. One more. Now this was for TSP. Now we are talking about PM10. What will be the composition? Everything less than this, right? Right? Again, mass will be dominated by bigger particles. If we are collecting size segregated aerosol, so that means we are talking about say we are 10 to 2.5. You are talking about from here to here, bigger size, lower size. Now you are collecting the aerosol in different sizes. Are you expecting the same composition everywhere? It will be. Okay. Now, depending upon what is your interest, you can find out. You can decide that what kind of sampling you have to do. Okay. Otherwise, say you are doing TSP and you are going to tell about source apportionment. So you will always say it is dominated by dust, right? Well, it will be dominated by dust. But if you want to say something about, say there are so many industries which are high combustion. In previous lecture, they were talking about the high combustion will give you fine particles, right? So that mass will be very small. So if you are collecting TSP, you will not see. But if you are collecting size segregated, then you will see certain size something is dominating, some other side something else is dominating. Okay? Whatever is there, mineral dust hair, whatever is there, why we should worry about? Why we should know the composition of aerosol? It means I'm talking about why studying aerosol is important.
Differential composition, the aerosol will have differential effect on climate health.
Climate health. Okay, so it will depend effect on climate or health will depend on composition. That is what you say. Anything else?
If you want to study something,
If you want to study something, you have to know the composition. Okay. Anything else? So broadly, when we say these are the, there are many more. These are the major things which why we study aerosol. Now, can anybody tell what is the role of composition in atmospheric chemistry? Answers are skewed. It should be distributed. Isn't it? What do you want? Separation. By
Atmospheric chemistry, like fiber and soot composition.
okay. So that is always one thing is ozone loss also. So it is that take positive chemistry that way. Any other way?
photochemical reactions.
Photochemical reactions. See, there are things. One is aerosol can provide surface. You know, for any reaction to happen, or it looks have to come closer, it should interact, and then there is some collision efficiency that okay, that when they will collide, then some fraction of it will be to protect. If they are in the air, there is less chance of colliding, but if they have some surface, they are coming close, then chances are more. So one way they are providing the surface. Then they also participate in that. So for example, dust is there, and then sulfuric acid vapors are there, which are condensed. Then it will react and will form the layer of secondary aerosol on primary aerosol. Okay. So that is how it affects atmospheric chemistry. Hydrological cycle. Many people are studying about this. Again, answers are biased coming from. I want everybody to involved. Please. Effect on hydrological cycle. Cloud formation. So, what is the role of composition? So, they can be hygroscopic, they can be hydrophobic. Depending upon composition, they can enhance or reduce the formation. Then, earth radiation measure. Absorbing or scattering. Most scattering type, sulfate, most absorbing type, lighter. Anything else absorbing? Brown carbon, dust. These are the three major components which are absorbing. Okay. Then visibility reduction. We know that. Human health. We know that. You know. When we inhale, particles also go in. When we exhale, they come out also. But fraction of it get deposited in our lungs. It can interact, and depending upon composition, it can have different effects. If you are simply inhaling natural aerosol, it will not affect much. But if you are inhaling some vapors, metal vapors, you know what will happen. Okay. And then this probably some of you will not be aware. It affects oceans, surface biological chemistry. Many of the aerosols act as a nutrient, but the phytoplankton in remote ocean. Other means remote ocean phytoplankton gets different either by appearing from the bottom or something getting supplied from the top. Iron is the most important micronutrient. And then nitrate, phosphate, carbon, these are the major macronutrients. Carbon is in plenty, we know that. But nitrogen and phosphorus, their deposition from the atmosphere is actually the supply of nutrients. So that is how they affect. To assess any effect of ambient aerosol, you have to know the chemical composition. In addition, if you want to say too much pollution is there, you have to identify the sources. For source identification, you have to find out, you have to measure the composition. Once you know the composition, you know that which source is supplying, and then you can plan the mitigation strategy to focus on those particular sources. Okay. Okay. Now, sampling. So something we already discussed that now depending upon what you want to do, you will choose a sampler. It can be HVS means high volume sampler, LVS means low volume sampler, and impactor, you know. I think this was their first or second lecture was there on this. High volume sampler means what? High volume is what? High volume means what do you call high volume? कितना में फ्लो होगा तो हाई बोलेंगे हाँ 30 liter per minute. That is not high volume. So yeah, हम माइक यूज कर नहीं कर.
It's 500 to 700 liters per minute.
So 500 or more. Usually whenever we talk about high volume sampler, it is 1.2 or 1.3 meter cube per minute. When you say meter cube into 1000, that is 1200, 1300 liter per minute. When you say low volume, it is about 1 meter cube per hour. That is about 16.7 liter per minute. Okay. So high volume sampler, low volume. And whosoever is correcting, how many of you are doing equally composition? 2 only. 3. Other people are not doing equal composition. ये इतना छोटा छोटा थोड़ा थोड़ा बड़ा कर लो यार. Very limited people are doing chemical composition. So I presume that you are learning something. If you have to do chemical composition, what are the things you have to consider? Okay. So depending upon your requirement and location, you can select the sample. Obviously, logistic is important here. Sample you can't give anywhere. So high volume, low volume is simple filtration. What is the difference between filtration and impaction sampling? Seven. I know something. Difference between filtration and impaction. Can you please tell them? He knows I know. Yeah, करना.
When we are collecting Packing means different size are going to add different filters.
Is it right?
So again, sampling we like that. By the gravimetric settling, and in impaction we use the velocity and the of the particle, and then to deposit for the deposition of the fluid.
Filtration means filtration. यानी कि एयर को फिल्टर कर रहे हैं using a filter. Impaction means it is getting impacted. We are not filtering. It is by impaction. This is impact. So unlike in this or this, you have pump. It pulls the air. You put a filter. It is coming through that. Filter has some pore size, particle. Majority of the particles. It doesn't depend upon pore size only. Majority of the particles you can collect on the filter. Because we are filtering the air. When you talk about impaction, 30 meter per minute here is under low volume filter. So you are pulling particle, and it has some design. Velocity is same for all, mass is different, so their momentum is different, and then you ask them to move here and there. So people like me who are attend fat, if you ask me to move here and there, means I will hit first, where lean and thin, they will pass through. Same way, bigger particles correct in initial stages, and small particles can keep going. Ultimately, you filter. So last stage is filter whenever you are connecting with the impactor. Okay. Now, if we match it with the previous slide. So we know the composition will be different. Composition will be same for this and this, depending on PM10 or PM2.5. For this, it will be different for different stages, because we know that we are collecting different type of aerosol on different stages. Okay. Sampling hours. What decides that? See, when we are doing sampling over city like Pune, Mumbai, Ahmedabad, Delhi, Kanpur, these things doesn't matter. But you will not be doing always this. Sometimes somebody asks you to go to Arctic, Antarctic, Mount always कर जाओगे at any some high mountain and sample. We have enough mass on the filter to get sunlight. Okay. After some time we'll be talking, means we don't have any control. Say, I will tell one example. We are involved in some study where balloon is going up to 20 kilo, and there is a sampler. Obviously, since balloon is going, so you can't put this kind of big sampler. So these are small samplers. Flow rate is 2 liter per minute, 5 liter per minute, and collection time is half an hour, 1 hour. I don't have any option. Whatever is I am able to collect, I am collecting. What we should do in that case, we will be talking about afterwards. But wherever possible, we are not in balloon at that time. We are at some place which is logistically possible, so we can increase the sampling duration. Right? Instead of, say, if you are in this kind of city, you can collect 8 hours off. But if you are in some remote place, increase it 24 hours, 48 hours. It will be integrated sample. So it will not represent, say, if it is 48 hours, I think it will represent those 2 days. But you will have sufficient mass. Okay, so you will decide depending on where you are. Okay. Then some points to be considered before maintenance whenever you are sampling. This is before sampling. Then position of sampling. Up, I ask you go to the sampler. You went into the sampler without considering what is you have in the surrounding, where the free flow of air is there or not there. But say somebody is, I ask go to Pune and collect the sample. Put the salas pe diya or somebody has put it a terrace. And obviously composition will be different. Somebody will say, no, this is the composition I measured correctly. Other person will say, no, that is the composition. Now, who will decide what is the right composition? So atmospheric studies, when we are talking about, it should be at least 15 feet or above. Try to put the sampler 15 feet or above. Then distance from the flow. So, अब यही पता में कोई इंडस्ट्री है उसका फ्लो आ रहा है, you are collecting, and then you are saying this is the major source. Then what is the need of doing the study? You can simply say without anything, right? So it should be not biased by surrounding sources. You have to judiciously decide what is the best place to locate. Put. Then calibration validation of instrument. You are going to, you know, when you calculate the mass, microgram per meter cube. Meter cube is important here. So that means you should know the flow rate. So time to time, you check the flow rate of your sample, so that you know that if you are saying you have 1200 meter cube, within 5% or so, it is that. And then, and see that we will be talking in the upcoming slide. Okay. So around 15. Okay. So I am taking away half of it. The remaining half you can take. So we will use the thing on it. So we started today. Okay. So once we have better report, by the way, today I am mainly focusing on filter-based measurement, because yesterday I know that you people enjoyed a lot. We have not taken you with you. You went to Mahabaleshwar, and there are many of the online instruments you have seen. Today I am mainly focusing on filter-based. So beauty of filter-based, there are drawbacks also obviously. Beauty is what? That from the same filter you can do wide variety of interest machine. No online instrument can give you all the things. But if you have filters, you can take different reports and measure whatever you want. Same filter, you are getting so many things. So one can measure numerous species which include water soluble in organic species. When we say this, it means we are talking about major cations and anions. What is major cations and anion? Chloride, nitrate, sulfate is major anion. Ammonium, sodium, calcium, magnesium, potassium, major cation. In addition, you can have sometimes fluoride also, which is rare. Sometimes you can have some organic ions also, like formate, acetate, and oxalate. But majority of the time, you get inorganic ions. Then you can do trace metals. This we will talk a little more about that. You can do water soluble organic carbon and total nitrogen, organic and neutral carbon, brown carbon, oxidative potential, which I added because I do. But means for chemical composition and oxidative potential, both are different. And dot, you know what it is. Okay. For this, now I am coming to that whatever title I have shown, intricacy. Now I am coming to that part. Okay. So what are these? Next section. If you want to do water soluble, you will extract with water. See, acid leachable and complete etch, both are different. Can anybody tell me the difference? Acid leachable and complete etch, and when we should go for it? One.
कंप्लीट डाइजेशन हम तब करते हैं जब जो मतलब इंस्ट्रूमेंट की स्पेसिफिसिटी मतलब पीपीबी लेवल या कंसंट्रेशन कम होता है तो हमें कंप्लीट एडजस्ट करना पड़ता है अपना फिल्टर ताकि कंसंट्रेशन हम उस अकॉर्डिंग
When is the leaching?
I don't know.
Okay. That is not the correct answer.
When we do the particles are in complex form, when particulates are in complex, first of all, acid leachable is just when we use acid like nitric acid or okay, sir. So when we directly want to get water, the acid soluble or directly extractable substance. But when we know there are some metals that are trapped inside the aerosol particle, so we need to break those particles trapped inside the aerosol. Means, sir, based on composition, like it might be that the particles soot if outside was the
porosity of some aerosols are porous. In that porosity, something is foreign inside.
Yes, sir. Like it is complex.
Okay. So then you do complete
direction.
Anybody else want to say anything? Okay, I also want to say. My turn. Acid leachable. Say you are interested in certain trace metals like zinc, chromium, cadmium, germanium, from the industry. In aerosol, if you leach with acid, everything will come in that acid, which is very simple. Leaching is simple. When we say complete action, now certain elements like aluminum or titanium, they will not be leached. You want to know the contribution of dust, or you want to study the dust characterization, then you have to completely dissolve. Plus, it will not be leached. Leaching is not constant fraction. You can't presume that okay, 50% is coming here, so I can double it or something. It will not be like that. You have to completely dissolve. Complete dissolution is a little complicated process. You have to use different HF, it's a very strong acid, HF nitric acid, and then hydrogen peroxide, etc. There's a bigger procedure. So, if your interest is not, you want to do zinc, cadmium kind of elements only, don't go for computation. Leaching will is sufficient, your work will be done. But if you have to do something that is dust characterization, then you will go for it. Then, if you are doing some organic compound, then you will use organic solvent. Other places I was saying water, I was naming the acid. Organic solvent I am not naming because different solvent extract different type of compound. So again it depends what type of organic compounds are of your interest. Accordingly you will decide the solvent, extract and analyze. Obviously it was ultrasonicator, if you want any acid work, if you are doing, always do in film. Because you inhale, obviously means you take this. But if you are inhaling those kind of acid continuously, it will affect. And this is chronic effect. You know the difference between chronic and acute effect. Chronic is slow poison. Slowly you are taking, you don't know means you are taking. Acute is immediately you have something, then oh, you will take care of that. Most of the aerosol effects are chronic, and that is why people don't take it seriously. ये तो बोलते रहते हैं, ये होता है, वो होता है, कुछ नहीं होता है. फिर पता चलता है 10 साल के बाद, 5 साल के बाद. Then how to ensure sample uniformity? Anybody? Now you are collecting on filter. I said you take aliquot. That means those aliquots should have same composition. Otherwise, from here if you are taking composition as something else, here you are taking something else. So that means you are totally reporting the wrong data, right? You have to make sure that sampling is uniform. Then here again sampling hour come into picture. You are talking about something sampling hour. This high volume or low volume sampler, they are designed to run for longer time. To get, वो देखा है कहीं पे means वो normal distribution के so many balls you put and then it takes some shape. But if you put only few balls, they will go randomly here and there. This number of balls is time. So certain time you have to spend so that your propulsion is uniform. Concentration is high, so then you can go for 8 hours. Okay, but 1 hour sampling if you are taking, it will not be uniform. But so say, I have to take 1 hour. If it is not uniform, but I can't do. I have this kind of sampler only, and I want to do our design. Filter I have many, so I can use what I choose. Volume means flow rate. Sampler तो वही है, काम से वाला है. Use the whole. Aliquot, when you are taking from here and there, then you can have non-uniformity. But when you are expecting the whole filter, so जो भी तुमने collect किया is on that filter, right? So you have to, so जितनी means whatever good understanding you will have, whatever the way you are collecting, the you are analyzing, your results, your data quality will be accordingly. Okay. Then importance of dealing of these items. We buy these things, right? Or buy your sitting Nano box and just set it. As a chemist, don't trust anyone. Don't trust. New virus I have taken, what we do, what technique we follow at PRL, we soak it in water, if I am doing water soak, and leave it overnight. So if anything there is in the water from inside, it will leach out in that water. Next day I will throw it, then Putin can lie with this, and then it will be. If I am going to use some metals, I use the same wire, but I make it PS2 or 2 normal sometime with it, and then we soak it. So N means metals have the tendency to get attached at the surface. So you will again reach the metal, and your wires are ready. Same way you are using syringe or filter, don't directly start filtering yourself. First filter some many whatever DNS bottle you are using, some 3-4 times just use it as a sample and throw it. That process is cleaning the whole system. Then you are using sample. Your contamination is less. Then this is very important part. If you are not there, who will work? So your safety is important. Depending on what you are doing, if you are doing some acid work, use proper apron, glasses, or sometimes splashes. Once you lose your eyes, they are gone forever. Sample एक बार चला भी जाएगा तो you can collect again. But if eyes are gone, they are gone. I don't know why I was saying use fume hood. Do acid work in fume hood only. And in addition to you, lab is also important. ये नहीं हम तो बच्चे ना lab गए, lab हमारी, you know how much effort goes. So make sure that whenever you are working, your safety and their safety. So I will not take more of your tea. Let us have tea, then we will continue.
We'll break for a short tea break, and please gather by 11:30 and continue this lecture.
Okay, audible? After the T, let us continue. We have already talked about it. Mine is not on. Now it is on. It was waiting you to say that it will be on. Okay, so now you are safe and your lab is also safe. Now let us move further. Different analyzer what we use for chemical analysis. What is this? OCT analyzer. Anybody knows the working principle?
ब्रेक झाला ना स्टॉप करून ठेवायची आणि परत स्टार्ट करायची. फक्त ते जे मेन आपलं युट्यूबला चालू आहे त्याला एंड झाला की संपला म्हणजे विषय. इथूनच खेळायचं जे काही
Thermal optical. It is called thermal optical method.
स्टार्ट केली.
So there is something thermal, something optical.
छोटं काय दिसतं.
I want interaction from this side also.
आता त्याचा फोटो तसं काय होतं डुप्लिकेट नव्हतं का?
Anybody knows
काय होतं डुप्लिकेट जागी?
how OCT works? Or if I ask you to plot the graph, can you plot? Yeah. Nobody knows OCT? Yeah, वो तो पता नहीं तुमने किया है कि नहीं किया, वो तुमने किया ही। Anyway, किसी ने यूज किया है OCT एनालाइजर? किया है? कुछ नहीं आता। बाकी छोड़ो, किया है तो वो तो क्या है? Means what I am trying, whatever you know, I am trying to add something. So if you are not interactive, it will not be of much use. Can you make a chromogram how it look like? हाँ तब होगा. हाँ ठीक है. You just put sample. And the regular user come and he. Okay. This is carbon. Okay.
You see the like 7 fractions. C4 then C1.
I'm sorry.
C2. So first we pass and we invert the gas. Even based on the
Yes, right. What is helium and then you put helium oxygen, right?
C4.
Helium plus oxygen.
Plus oxygen for the element. And so
And this is what?
carbon monoxide.
Some unit, whatever carbon level. The detector is FID, flame and insulator. We are putting some methane as a constant supply, which is internal structure. Now I will take it.
And this
Achha, is why we call it thermal optical, you know that?
yes, sir. Thermal is because of the thermal base and
Because you are heating.
yes. Also we have that on 7 wavelengths we have to measure the based on wavelength also it measures fractions.
That's what.
Measures the
This is your target. Transmittance and reflectance. Okay.
follows a baseline.
Okay. So he made something. I'm not going to make it better. So you get some signal as a function of time. This method is called thermal optical method. Why it is called thermal optical? Because you put the sample array cord on a board. This is something which is called board. You put the filter inside, and then wherever you are putting, that temperature can be. Means you can change the temperature. So there are some protocols, established protocol, which is NIOSH 5040 or improved or some European protocol also. There are some protocols where they have defined For this much time, it will heat the filter for, and then it will switch. Then again it will heat for this much time. Again it will switch, and so on. For each different temperature, you are getting some oxygen coming off. You are oxidizing it for ultimately to CO2 and then reducing it to methane. And then from methane you are using. That means for each temperature you are getting some OC. So first temperature is called OC1, then OC2, OC3, OC4, and like that. Then the same instrument gives you EC also, elemental carbon. Now you are using methane, which is coming from CO2, and CO2 is getting formed by things which are coming off from your sample. Now how instrument know whether it is from OC or EC? Why I especially wanted to tell this thing, because many times people don't understand the meaning of split line. There is something called split line when you make this figure. Because, can you read this? Whatever is written? This OC1, 2, 3, 4. And then he wrote PC, paradise carbon. So once you are burning organic carbon, part of it is converting into elemental carbon. And some elemental carbon which was collected on the field. So now we have a mixture of both. Something coming from organic carbon and something which was already there. Now how do I know that what is coming from OC and what was already there? For that, you use optics. So what you do is when we start, you flash certain wavelength, 6, 7, 8 nanometer we use, and depending upon the elemental concentration. You know, organics are scattering type and black carbon are absorbing. So it absorbs. So some intensity of flashing and there is some transmission depending upon the concentration of elemental carbon on the bit. Once you start hitting, what happens? Things are coming off. But elemental carbon is forming from organic carbon. You are putting more and more organic carbon. So transmission should increase or decrease. Transmission should increase or decrease. I decrease this decrease because you are getting more elemental carbon. You are stopping the light passing. That means initially something was say here, then it will come down. Okay. Now you are mixing both elemental carbon plus whatever elemental carbon coming from organic carbon. You are keep heating. Okay. And this all heating is in pure helium atmosphere. Helium is inert gas. So whatever is coming off is all because of thermal decomposition. After a certain time, you switch and you start injecting helium plus oxygen. Oxygen is obviously oxidizer. Then it started oxidizing. So now whatever elemental carbon was there, that also get oxidized. And both elemental carbon getting oxidized. Whatever came from oxygen, organic carbon and whatever was already there. Now this PC. So first elemental carbon will coming off. What will happen to transmission? It will be decreasing or increasing? Increasing now. Because we are removing the elemental carbon. It will increase. So the point where the transmission is same as what it was initially. That is the split point. Because what you assume here, that whatever was added, transmitted decreases, and again once it is coming off, again when you reach to the same transmission which was earlier, that is the split line. So this fibrillized carbon is OC4 to that split line, that is fibrillized carbon. Fibrillized is coming from organic carbon, that is fibrillized carbon. And after that whatever is coming is elemental carbon. Is this clear? This is something which you don't get OCC split line. Once more, transfer. What means? What is the point? What particular point?
It's also a temperature. So now are we saying that the transmittance should be same as like after OC4 when we inject oxygen and same as initial like
Okay. So I am repeating. You put the filter. There is some transmission because the elemental carbon present there. Okay. Then we started heating in inert atmosphere. So only thermal decomposition. Things are coming off, getting oxidized, forming CO2, then you are reducing into methane and methane. Part of it getting into converting into pyramidal carbon. That means you are increasing your internal carbon on the equator. Because of that, transmission is decreasing. Then when we switch to from helium to helium plus oxygen, then everything start getting oxidized, and temperature is not constant. Temperature is there is a cycle for it. It is not that means it is one value. You can do, if you are using OCC or rather, you can make your own protocol also. There is simple watts.par that is there. Some code you will change, some changes instead of say 20 minutes it usually take, you can make it in 10 minutes. You can instead of hitting in 1, 2, 3, 4, you can hit at one shot also. If you are developing some protocol. But otherwise, to be safe, we just follow some protocol which are already established and say that we follow this protocol and from that we are getting this concentration. Now coming back to that, once you change to helium oxygen, temperature also comes down. Then everything is getting oxidized. Transmission is increasing. And at one point, it is same as whatever was there initially. That is the point. OC4 to that point is less carbon, and after that, elemental carbon. Yeah. Now there is no standard. Again, if you are running this instrument, you know there is no standard. At the end, you will inject some more amount of methane, 5 ppm methane, and it is giving some signal. To 1 point calibration, 100 रुपए का इतना तो 2 रुपए का इतना, those types. Yes, you are injecting some known amount, getting some signal, and from that you are whatever signal you are getting, back calculating the how much concentration you are getting. As a good analyst, if not just this, what we do, we first run it blind. When we run blind filter, whatever is there comes off. Now consider there is nothing more after running. On that, whatever you are using quartz filter, whenever you are using this PCOC, you will use quartz filter only. Otherwise, you will kill your system. Reason I will ask about. So now instrument doesn't know whether you are doing sample or what. Then I pipette some 20 microgram of sucrose on the filter. I know that I have put 20 microgram. System doesn't know whether I am getting sample or what. And then I again put it. If I am getting 20 microgram within 5% as 20 microgram, that means my system is ready. If not, then we have to see some calibration constant, those kind of things are there. First, we have to precisely means you run it again and again. And every time, suppose instead of 20, you are getting 25. Then you have to adjust some calibration constant and make it. So this is the way you make sure whatever you are producing is right. Okay. Now, watts. Watts is the component which can hold very high temperature. What are the other filters we can use? Teflon, glass fiber, nylon, many filters we can use. But if we are doing OCC measurement by this method, we use glass fiber because that hold at that temperature. Otherwise, filter will also come off. Teflon also. So Teflon will give you very high signal. Teflon is also opening, right? So you will not know what is coming from filter, what is from sample. You use glass. Okay. Then major lines. Who is doing major lines? कोई ना. हमने देखा कि नाम नहीं सुना हमने असर इसका. और कोई नहीं कर रहा. बहुत बढ़िया तरीका है. हमने मतलब आगे सुना है हैंड मूव होता है. मेजर लाइन भी कुछ होता है. वहाँ पे दिखाता है रियल. और उसके बाद भी सब शांति में. सब फोटो खींच लेते बाद. Hand photograph. Now we will recall whatever I was saying before the thing. That we don't have option. I am collecting filters, but I don't have option to program for longer time. As I said, I am going to the balloon. Balloon is there for 1 hour only. And sampler is with that flow rate. That means whatever I have collected, I have collected. Now if you can measure. If you don't measure, say it is irrelevant. So how to go for low and low detection when you're using anemograph. Honestly, nobody else used anemograph in anemograph. So, first, ऑब्जर्वेशन यूज किया तीन बाकी थोड़ा थोड़ा ऐसे ऐसे कर रहे हैं हम हाथ जो उठा रहे हैं बता भी नहीं क्या आई नो ब्रदर never you do what I said to this person then you inject it there is something called injection volume okay usually you will keep around 20 to 25 microliter of injection अच्छा सिंपल लॉजिक है यहाँ कुछ तुम्हें केमिस्ट्री आती है नहीं आती डजंट this is a column you know this is a column where you number of ions will be some number of ions will be there hello okay by the time bank is getting repaired I will speak a bit loudly so we have a column we injected 25 microliter into your hand right okay is it working how it is working so column doesn't know anything whatever you are injecting so if injection volume is say 25 microliter in that 25 microliter there is some volume so some number of ions will be there some number of sulfate ammonia calcium etc will be there it will go inside the column get on different sides and elevate now I have a very less concentration in the sample what I can do I can inject the injection volume so instead of 25 microliter suppose if I inject 100 microliter that means 4 times more ions I am putting right so whatever area you are getting earlier is 4 times more that means you have increased your detection limit by 4 times by increasing the injection volume okay only thing you have to keep in mind so if you are increasing the injection volume your standard and sample both should use same injection volume so if it is same then it will not come into calibration otherwise if you are doing calibration with 25 microliter but injecting 100 microliter it will create a okay so that is how if you have to get something at low concentration you have to use some other ways to get to the texture okay then this is OCTM and the OC is total organic carbon, TN is total nitrogen. If you recall, when I was showing the 20 species you can measure, in one of them I said organic nitrogen also you can measure. But there is no instrument to measure organic nitrogen. Instrument what we have is we can measure TN, that is total nitrogen. And मेजर नाइट्रोजन क्या है अमोनियम and nitrate both have nitrogen so they are called inorganic so inorganic nitrogen we know total nitrogen we know you can calculate from the difference how much is organic nitrogen can anybody tell how when we do this kind of subtraction remember you can't simply subtract you are saying here you measure 5 microgram per liter and ammonium plus nitrate is 4 microgram per liter you can't say that 1 microgram per liter is your organic nitrogen why not कोई भी इनऑर्गेनिक आयन का काम करता है कोई मिसिंग व्हाट no we can do and everyone I my own tell I want one volunteer and अच्छा बढ़िया तरीका है उसको दे दिया नहीं जब ये नहीं है एक जना कोई आएगा वही इसीलिए बोल रहे हैं, लेकिन आउट यहाँ पे करते हैं। अरे भाई आओ आशीष, ये लोग जानने वाले हैं उनको पकड़ना है, तो नाम पता नहीं हमें। सब सबको बुलाएंगे भी। सी ammonium 10 microgram ammonium, but in terms of mole, if we say how much nitrogen, we say moles, mole and microgram is the difference. So 1 mole of ammonium will be how much microgram? One micro से microgram easy रहेगा. 1 micro mole of ammonium is equal to how much microgram? 18. Why? Because nitrogen 14, hydrogen 4, 18. So 1 mole of ammonium has 18 microgram mass. इसमें nitrogen कितना है? 14. That means 14 by 18. In fraction wise, if we say 14 by 18. When we are talking about nitrate, 1 micromole of nitrate is how much microgram? 62. 14 plus 48. 16 into 3. Oxygen 16. NO3 है into 3 48 हो गया plus nitrogen 14 62. Nitrogen कितना है उसमें 14 हो गया. So if we say fraction of nitrogen, it will be 14 upon 60. So that means mass wise when you say ammonium and nitrogen concentration may be equal. But अगर nitrogen की बात करेंगे तो ammonium is contributing much more than nitrogen. So that is 14 by 18, almost close to 1. This is very small fraction when you say nitrate. So first you convert into micromole. Same thing you convert total nitrogen whatever you are making into micromole and just subtract in micromole unit and then again convert to micromole. Then one can ask कि बाद में करना तो पहले ही करेंगे. When you convert from micromole to microgram, you should know the amount of formula. Nitrate के लिए NO3 62 हुआ था, अमोनियम के लिए NH4. लेकिन अमोनियम दोनों केस में 14 था, राइट? नाइट्रोजन 14. सेम वे टीएम में करेंगे उसका भी 14 वाला ही निकालेंगे, वहां से जो आएगा it doesn't matter what is corresponding other elements, we can calculate that way and then convert back into micro. Okay, करते हैं आपको समझ आ गया? nitrogen, nitrogen. Yeah. Okay. 14 by 18. This was 14 by 60. We will convert to more. Then again come to mass. Okay. Still right. From the unlike all other instruments, brown carbon is slightly different. Brown carbon is not one species. What is brown carbon? We can tell. Bura carbon. Some organics. Some organic compound coated with aluminum carbon.
So this substrate of organic carbon light absorb bacteria.
Right. The way aluminum carbon absorb, same way certain type of organic carbon are absorbing in nature. They are called brown carbon. I am not going today in that detail. from carbon. But that we take it from that certain fraction, but we don't know the compound. We know that some compounds are there which are absorbed. What we do, we measure the absorbance of the whole extract from 300 to 700 nanometer. And then whatever absorbance you are getting, there are some way to calculate. From there you calculate, and you don't report from carbon in terms of microgram per meter cube, but you report in millimeter per millimeter. Then GCM for routing specification. So in previous slide we were talking about, depending upon your interest, you will select different solvent, extract, follow the procedure, and run on GCMs. GC is gas chromatograph, which is same as line chromatograph. The principle is same. You are putting in some column, they are getting absorbed, and with time they are getting dissolved. They are coming off. In case of ion chromatograph, you have conductivity detector. In this case, you have mass spectrometer. So your sensitivity is much better. You can go at very low concentration with GCMs. And then you have for metals, you could use AAS or ICP-AAS or ICP-MS. किसी ने ये यूज किया कि ये भी किसी ने यूज किया, सवाल ही पैदा होता है. I know some people who are doing metals, they are also not telling. So what we do, acid leachable or complete etch, whatever that was depending upon what was your interest. Now we have sample in solution form, which when you are using AS, flame AS, in that case for each element you have to put different follow control. That was, it is using single wavelength. It is based on absorbance. You put some wavelength into the solution, that whatever species which absorb at that wavelength will absorb it, intensity will reduce. So you know I0, I, from that you make some calibration and calculate. In case of ICP-AES, same thing, you put everything in plasma. The first class he was talking about plasma. You put things in plasma, everything get ion. And then things comes back, they emit different wavelength. So emission spectroscope. Whatever wavelength are now it is emitting, you measure them, calibrate them, and get the point. ICP-MS, again, you are putting things in plasma, you are separating them by M by Z, the mass to charge ratio, and then putting it to detector and getting the concentration. Sensitivity wise, ICP-MS is most sensitive, can go at very low concentration. ICP-MS can go to PPT level with ICP-MS, PPT. With ICP-AES, you can go sub ppm level. With flame AES also you can go sub ppm or ppm level. So again, depending upon what you are maintaining, accordingly you select. जहाँ पे स्विच चाहिए वहाँ स्विच इस्तेमाल करेंगे, जहाँ दरवाजा चाहिए वहाँ दरवाजा इस्तेमाल करेंगे. जहाँ पे स्विच का इस्तेमाल वहाँ दरवाजा लेके जाएंगे तो फायदा नहीं होगा. So in your sample, certain species take calcium magnesium are usually very high, and you want to use ICP-MS for calcium magnesium, then it has no meaning. But if you want to use some lead, arsenic, which are at very low concentration level, then you are using that instrument. Okay. Now calibration and pattern. अब इसमें कोई नहीं बोल सकता कि हमने नहीं किया. Calibration तो क्या ही होगा? Any instrument. What we do for calibration? What we do for calibration?
concentration के साथ actually do different concentration पे more concentration पे उस factor को use करते हैं.
Would be grease or somebody else is doing some other way calibration. Is doing the right thing. We put different standards, get some output, make calibration curve, and use that calibration curve for sample. Right. This is what we do. Right? Standard concentration, the instrument output can be anything, depending upon what kind of detector you have. I'm going to last some area they go. Somewhere you can get some millivolt, absorbance, instrument output, whatever. So that you put on y-axis, concentration you put on x-axis, make calibration and use this calibration for here. Here I put something, r square would be close to 1. Because what is the meaning of close to 1? 0.8 is okay? 0.7, 0.8. When I'm saying close to 1, it means I'm talking about try to be at least 3 length. 0.999. Then your calibration is good. Sometimes at very low concentration, you are running the standard at very low concentration. 998 तक भी कर. लेकिन अगर इससे नीचे आ रहा है तो ये calibration is not. Now, what is C here? Volume. Intersect है. From where is it? Is we are injecting some standards, getting some output. So it should be linear. And if I am not putting any standard, there should be no output. That means you should pass through 0. But you are getting some value without putting any standard. What does that mean?
Already had available.
That means system has some concentration. You run the system without injecting anything. If you are getting some signal, that is called system. These blanks how we are system blank means running the system without putting anything. So from system itself something, say OCT we were talking, don't put any filter. Run it, still we are getting some carbon, that means system is contributing some carbon. Then reagent blank, filter blank, field blank. Sunan? Sunan. Reagent blank. We were talking about extraction. You were using water or some acid bleaching, completion, organ solvent, whatever you were using. Those are reagents which you are using to analyze. And you are using those reagents to extract your sample. But when we run sample on the instrument, if reagent say you are getting any species, which example is sodium, you are getting sodium, but whatever molecule you have used, it also has some sodium. That means whatever you are going to get will have sample plus molecule. Right? Same molecule you have used to make the standard. That means in every injection, that much contribution is coming. So in principle, this intercept is telling you that how much sodium concentration is there in your urine. Without the standard concentration, you are getting something. Okay? So that is reagent. Then we are using some filter. R square. देखिए validation की calibration की बात करेंगे. This is calibration, and calibration means you are doing with some way. Majority of the times you are using this way to calibrate. When we talk about OCT laser, whomsoever is using, you are not using this way. तो माने वाली क्या use कर रहे हैं OCT laser, but you don't use this calibration. I was telling that you add some. I was telling that we add some 20 microgram on filter and run it as a sample. Because system has internal calibration. Every run you put some 5 ppm methane, and that signal you use as a reference because better concentration in your sample. But majority of the instrument, this is the validation is a different thing which has become whatever data you have produced. Now, how you can make sure that is correct? Instrument में कुछ डालोगे कुछ तो निकल के ही जाए. How to validate that is correct or not? We will talk about that. Filter. Now you have collected samples on some filter. Filter also can contribute. Same way the way range was contributing. So if we, so whenever you are running any sample, some blank filter also you run. Presumably that it has sample. And see whether it is contributing anything or not. That blank you have to subtract from the sample. And then last is field blank. What is field blank?
सैंपल करेंगे तो उसमें से माइनस कर देते हैं की डिफरेंशिएशन.
So here what she said that suppose you are collecting filters on the terrace of this building. Whatever time you are collecting filter, you just put the filter. Don't put on the limit for same time for whatever time you are collecting and bring it back. So that will tell that by simply putting the filter without filtration, is there anything you are adding? That filter. Now I am doing all the things, but I want to know that I did all the four, but I want to know what is how much is coming from blending. How I will do that? I should know how much is reagent contributing, how much is filter contributing, how much is fluid blend. You should know. In principle, again, blindly करना है तो बोलो fluid blend सबसे कर. कोई कहाँ से ले आया? But if you want to do with understanding, you should know that whether the reagent you are using is good enough, there is no problem with the reagent, or the filter you are using is good enough, it is not contributing to the blank of the signal of your interest, whatever element of your interest, or filter. कैसे करेंगे? One by one. अलग ले रहा है. But by bias. One wire I simply put them and then make the same. One wire I extracted filter length. So it will have LQ plus filter. Third I am putting field blank. Now all are coming same. What does that mean? Everything is wrong. So what is there? Everything is wrong. If all are coming same, what it means? It is from the LQ is contributing everywhere. Filter and field blank are not there. Same way, LQ is low, but filter is high. From that, you will know that filter how is contributing. And same way you can do for the filter field blank. So this is how you can find out that what is contributing how. Anytime if you are doing any analysis, please do it in your mind so that you know how much is coming from where. That is involvement. Data otherwise हम बोलते हैं कि हमने तो subtract किया था, we have to subtract करते हैं. ठीक है, क्या सही है? But you don't understand. Then data code. In case of major ends, now again, I was saying if you are injecting something, you will get something. How do you know that whatever you have measured is correct or not? One is charge. अभी कोई चार्ज बैलेंस बोलेगा कि फिर सब चार्ज बैलेंस हेलो sum of curtains minus or divided by sum of curtains. कैसे निकालते हैं? My equivalent. Convert that into equivalent. Now why I am saying equivalent? Say ammonium is reacting with sulfate forming ammonium. अमोनियम का मास कितना होगा? एक अगर मोल की बात करें, एक मोल का हो जाएगा 18. सल्फेट का कितना होगा? सल्फर 32, 64, 96. यानी कि 18 माइक्रोग्राम अमोनियम रिएक्ट कर रहा है 96 माइक्रोग्राम सल्फेट. अगर एक मोल रिएक्ट कर रहा है, लेकिन in terms of mole, if you will say, one mole is reacting with one. Whenever we are doing charge balance, we should first convert into equivalent. I'm not converting into molar, but equivalent. In terms of equivalent, whatever cations you have, same amount of energy. We are building ammonium, sodium, potassium, calcium, magnesium, and we are building chloride, nitrate, sulfate. Convert everything into unit, then you balance it. Take the ratio of ratio is the best thing. Take the ratio. That ratio is coming between 0.9 to 1.1. That within 10%, you are balanced. Ratio is coming 2. Now, anion is 2 times higher than cation. That means there is something, if your measurements are correct, there is some major element, this cation is missing from the analysis. Same way, if it is ratio saying 0.2 to 0.3, that means something is missing. So from that balance, you will come to know that whether anion or cation is missing from the analysis. Then,
like sometimes we see that there is sometimes dominance of cation based on the sources. So, like if it is coming from a diesel generator or something, it will have a lot of sulfate, and so it will suppress other ions. So, what in that case we can say?
we are trying to find out whether what anion or cation is missing, and then I will also tell you that what we infer from that. How to validate whether that particular anion or cation is missing, and how to validate. इसको इरेज कर दो, एक का cation को एक का anion. You know the formulas. See, whenever we are doing such kind of interaction, you know that we are not going to do it every day. Are you ready? So, you like, I know many people are doing this analysis, but keeping the mouth shut is convenient. वो लोगों को फिर मुझे क्या सोचेंगे, पता नहीं वहाँ पे अच्छा नहीं लगेगा, लोग क्या सोचेंगे, जो लोग सोचेंगे वो खुद नहीं बता पा रहे हैं क्या सोचेंगे. एक patient. Okay. Okay. And it's okay. Sulfate is so. And also for 2 months. Just these are the things we measured and we found that ratio is between 0.9 to 1.1. Correct. Now, if we find that anions are less than cations, so say anion upon cation ratio for 57.7. That means there are some missing anion, right? What those missing anion can be, what we should do, then take the difference. Cation, sigma cation minus sigma anion, you will get some value and plot it against calcium plus magnesium. Because calcium plus magnesium usually come from dust in the form of carbonate. Carbonate we are not building. So if calcium plus magnesium is balancing the difference, that means whatever we are not getting is the one. That means missing anion is carbonate. You getting what? Here, missing anion is carbonate. Now, what you are saying? Now, suppose sulfate nitrate chloride upon anion when you get ratio is coming 1.3. That means you have some missing cation. You have more anion, 30% more anion than cation. That is usually missing cation is hydrogen ion. Hydrogen ion means it is sulfuric acid. If you have sulfuric acid in the atmosphere, you don't have sufficient cation to balance. Then it will remain either sulfuric acid or SO4. Stress we are not building. The missing is stress. Those aerosols are ideal state. From the difference, you can find out. Most of the time, over Indian region, we get less anion. Because we have dust, lot of dust. That's why most of the people don't believe carbonate. But if you are in some pockets, goes to, say, for example, some a thermal power plant or some industry which is putting too much of acidic component, then it may happen that way. Yeah. Yes. Then other part is cross calibration. And this is one cross calibration of the cable. Certified. Certified is not cross calibration. I will tell you. Say whenever we are making some standard, there are two ways. One is we buy some salts, say ammonium sulfate, sodium chloride, etc. We bought. We weigh certain amount to the velocity class and we made it by ourselves. Then there are some commercially available standards. Okay. The commercially available, whenever they are selling, they have to certify that concentration is there. Now I have bought, say, from Mark or somewhere I bought an standard. I measured chloride. Okay. Then I took some sodium and I made standard from that also. Now whatever calibration I made using this commercially available standard, I run this lab-based standard of that. So chloride should come chloride, whatever concentration I am putting on that calibration. That will tell that whatever you are making in the lab is correct. Now I can use the same for methyl also. So from this I know chloride is correct. That means corresponding sodium also should be correct. If that sodium I run on lab-made standards and sodium is coming properly. That means in a way, using one standard only, I am cross calibrating that whatever analysis we are doing is correct. Again, I am repeating, these things will not find in any books. It comes with experience. In prayer. अगर ते हो बात करो नहीं करो तो आएंगे. Okay. For OCC, I already told you. So I also बोलना.
Using the different instruments for and posing them to the same ambient conditions, we can say that we are cross calibrating.
I'm coming to that also. So he is saying same component. I used one way and same Atomizer I used for electrostatic. But Atomizer is online instrument. I-28. So you do another method you use that. And for two different methods to give you the same result. Then in a way you are cross calibrating and that is the whole thing. I'll be talking about that. OCC I already told external standard. I put some filter, I put one amount. Instrument doesn't know whether you are putting sample or standard. From there, you know that your system is running fine or not. For metal and optic depreciation, I'm asking you to use the standard level. Now, earlier I was saying you can simply use the salts, the ammonium sulfate, sodium chloride, etc. Here I am not saying that simply use some compound and then measure. Try to use the standard level. Why? Because here matrix is also important. Now, what is matrix? That's the problem. इसकी बात नहीं कर रहा. Matrix means when you collect aerosol, there's some metals are there. Somebody was talking about this porosity उसके अंदर अगर कुछ है, तो when you collect aerosol, variety of aerosols are there. So, say too much of dust and some metals are there. You are extracting from there. So how good is your extracting efficiency? That is coming to picture. So for that, if you are using standard reference material, which is again aerosol material, and from there you are doing the SRMS, you know the concentration. You extract it and measure from your calibration. Whatever calibration you did from there, you measured some SRM, and it is giving you within 5-10%. That means your whatever procedure you follow is correct. If not, you are getting off too much, and your extraction procedure or something is wrong somewhere. So these are the ways to make sure that whatever analysis you are doing is good quality or not. Okay. Then this is for all the Earlier I wrote from mineral for OCT. Majority of the people use pipette. Now tell how many of you calibrate it. You are using 1 ml pipette. You are assuming that if it is 1 ml, receiving 1 ml. How do you know that? So what we follow, balance water skill level. We know the density of water. One क्या? 1 gram per centimeter. That means 1 ml अगर हम पानी लेंगे तो उसका weight 1 gram होना चाहिए. 1 ml की pipette है. I took the beaker, tear it, and added 1 ml, and see what is the reading. If it is coming 0.999 or 1.001, fine. If it is showing 0.9, so your all calibration are based on those 15, right? So you are biased throughout, which you don't know even that you are biased, because you are doing everything very honestly. So whatever you are, don't touch. I told as a chemist, don't trust anyone. तो अभी जो भी यूज करता है अपनी pipette में चेक करो. फिर वॉल्यूम लेते हो 15 ml. ये 15 ml में एक्सपेक्ट करा 15 ml में कैसे करो. आमतौर पे डिलीटेड ट्यूब्स होती है, means you just take from it. Make sure that 15 ml you are saying is 15 ml. Otherwise, this will all add to your error. अभी बताओ, बताइए मैडम. लंच के लिए ब्रेक करके फिर आगे कंटिन्यू करें या अप टू ठीक. Almost time. Yes, if they are not interacting, I can finish in 2 minutes. If they want to interact, some places I am interacting, I am trying to involve you because I want you to understand this. Okay, that I don't want you to go fast. Take time. Sea salts. We know this. We know sea salt composition. This one is sodium here, then chlorine, sulfate, magnesium, calcium, potassium, and others. In terms of concentration, in terms of percentage, everything is equal. We know sea salt is among the major natural sources of oxygen, okay? Especially when you are close to coastal region. When you are too much inland, then by that time actually you won't get that much. But if you are close to coastal region, you have sea salt. Now, sulfate is significant from sea salt. And sulfate you are also getting from sulfur dioxide oxidation from power plant. Now, how do you know that whatever sulfate you have measured is from sea salt or from power plant? So, for that, what we do sea salt correction. You must have seen some formula for that. I want to tell while using the formula what are the things to keep in mind. Again, you can simply blindly with that paper you try at all. I use this, so I also use this. I will tell you some reason what we should think before using the formula. So if all these components are present in the salt, from sea salt, what relationship we expect. Now, reference element, majority of the time we use sodium, right? Whomsoever is doing this, we use sodium. But you can use actually any means. You saw the composition, the last pie chart. You can use chloride also. You can use calcium magnesium. We should prefer conservative. Now, can anybody tell me the meaning of conservative? Conservative. बहुत बड़ी. And I notice whenever I ask many people को नीचे लिखना है उसमें बहुत जरूरी चीज लिखना चाहिए. Don't change your time. Or change your time. Don't change. So conservative elements are those, say some chemical reactions are happening, but they will not change. This sodium chloride plus sulfuric acid. since sea salts are coming and you have power plant, sulfuric acid you are producing, they are reacting. It will form sodium sulfate. It will remove chloride, but it will not remove sodium. That means sodium is staying in the system. So we call it conversion. So sodium, calcium, magnesium, potassium, all are converted. Now, how do we know that whatever we are using is correct or not? So I had put this. With respect to sodium, I put all other lines here, and I put some slopes, which if you have noticed, it is similar to the percentage composition what we were showing. I put the ratio. So what one should do to whatever sodium chloride we have made all of that, to throw those points on these plots. Take everywhere, if the points are falling above this red line, it has some meaning, and in some cases, points are falling below this line. Then also it has. Can anyone tell what it means if points are falling above or below? इसी वाटर लाइन मतलब सुना गया. इसी वाटर लाइन is the ratio of these species in C1. Now, since we measured in our sample some concentration, and we have whatever we say 100 sample I measured, I put all samples on this plot. Use whatever sodium and chloride I measured, then I put on X and Y, and everything is here. And then I took the slope, 1.8. Things are falling below line or above line. What does that mean?
Line means excess which is the concentration.
Why is it below line is?
कि y axis पे जो प्लॉट किया है हमने उसकी concentration की variability show करेगा और above means कि जितना x axis पे है उसकी variability.
X y plot किया है. For each x value we have the corresponding y value. If everything is from sea salt, all the points should follow on this red line in all the cases, right? Plus, there is no other source. The composition should remain the same, so they should follow this slope. Here, this in the upcoming slide, I want to tell you how to use the slope when you are plotting for understanding the data. So, if things are from sea salts only, all the points should fall on these red lines. If they are falling, say for example, यहाँ पे आ रहा है, that means you have chloride more than sodium. Whatever is expected from sea salt. In addition, you have some chloride. Right? Same way, anywhere your points are falling above line, that means y axis, whatever thing you have, it has some external source. But it also confirms that sodium you can use as a reference element. Because no point is falling below. Suppose if points are falling below, that means in samples sodium is getting calculated from some other sources. So if you are in that case also filling with sodium as a reference element, whatever calculation you are going to do, you are doing is wrong estimation. Right? So this is the way to find out whether whatever reference element you are using is correct or not. Okay. Then this formula again, sum it all. You use this formula. So sodium reference element here, this whatever slope is this. You multiply whatever is expected from sea salt is this. This is what you have measured. If you subtract, you get the non-sea salt concentration. For sulfate, calcium, magnesium, etc., calculate non-sea salt concentration. And here I have put some ratios. In C, these are the ratios. This is in equivalent unit, and this is in weight. Sea salt calculation easy. Whatever you have to keep in mind, that you make sure that whatever reference element you are selecting is proper. Okay. Now, minerals. Again, this is the composition of UCC, upper continental crust, average upper continental crust. So what you have in the crust, this much oxygen, you go to measure, or silicon, then also you go to measure, and then aluminum, iron, calcium, potassium, etc. etc. These are all major ions. Major ion, minor ion, and trace ions. Is there any criteria to follow? Sometimes you say major. For example, for dust, I will not call ions, I will say major elements. Ions means it has to have some charge. Element means it can be some oxide form also. I will say these are major elements. Then others, there are so many, 50, 100 species, they are there for this. So there is some way to say then when you will call something major or minor or trace. You know that? More than 1%? Yeah. 0.01%, minor, and less than 0.01% is traceable. Now what is 0%? If I am saying 1%, is for out of total. This is so trace elements, since out of total they are very small amount, that is why we call them trace elements. Which can be what you see these like this. Suppose some other type of sample, for that particular type of sample, major, minor, and trace element can be different, depending on what kind of percentage they have. Okay? And for that, again, it is similar to this calculation only. You calculate a different way. Here, aluminum you use as a reference element for your dust. Again, here also same thing applies. Say you have all these ratios available. Now something if it is getting lower than this, that means aluminum has some extra source. In that case, people use titanium. Titanium usually doesn't have the source. But mostly people use aluminum as a reference element when doing this dust estimation. So from this ratio, the ratio is 1. What does that mean? Independent factor is 1. What does that mean?
No enrichment.
No enrichment. That means everything is from dust only. 2, 5, 10, 100, 1,000. More the number, that means for that particular species, there is some source which is contributing. Usually for trace metals, which are coming from this volatile trace element like zinc, cadmium, etc., get 100, 1,000, 10,000, that kind of any contributor. That means they are, dust is not the reason for whatever consumption you are doing. So if you have, say here I have written 1 to 10, you consider it as dust, because dust is like somewhere from it tone, fall back, tone, fall back. So up to 10, don't worry, you can say it is majority from dust, but more than 10, higher the number, more the contribution from non-dust sources, obviously including sources. And whatever I said, higher the value of return factor means more the contribution from non-dust sources. Simple, very simple. If you assume aluminum from dust, there is a simple way to calculate dust contribution. Many times people use different elements and their oxide and then calculate. This is very slow. Same way in case of sea salt. Suppose you want to calculate the total sea salt. So sodium into 3.5 will give it sea salt. Why? Because 35 grams per liter is the concentration of total salt. Out of that, 10 is sodium, 3.5 is the factor. Okay. Now, Now whatever I am showing has nothing to do with chemistry. तो अभी इन्वॉल्व नहीं हुए तो नहीं रोक लेते. Why multi? You want to stop here? Don't get in. But if you want to discuss, we discuss. ये bulk organic I'm saying, see when we say organic carbon, we mean organic carbon. Organic carbon, there are thousands of it. But we are saying total, how much is organic carbon? That is why I am saying bulk. Same way when we say water soluble organic carbon. Again, whatever is water soluble, you are telling that. So that is bulk. Speciation is when you say this much is pH of that particular type of pH or carboxylic acid or alkane, then you are talking specific. इसी टेस्ट मेथड होना है. We will calculate primary and secondary organic carbon with this. Okay. Now, soon. We will calculate this way. And what is the way? That you here OCT is concentrated. No, and here say 100%. Not means in the Excel file I put and I found out the minimum ratio. Here the assumption is that the minimum ratio whatever you are getting is from primary source. Okay. So that means somebody told me that what is the difference between primary and secondary. EC is always primary. Can EC be secondary? It cannot. EC is always primary. OC can be primary or secondary both. Okay. That is what we are trying to find. Then whatever organic carbon we are getting, how much is primary, how much is secondary. So if it is sources are similar, so OC to EC ratio will be similar in those samples. We are utilizing that assumption. So we know that certain ratio is from some primary source, and we know the EC concentration. If you multiply ratio with the concentration, you will get some OC concentration, which is equivalent to the primary organic carbon. That is how you calculate POC. And from total, if you subtract POC, you will get SOC. But this is a vague method. It's not very precise method to calculate. But people use this a lot, especially when they are doing category. यहाँ पे the important part. Now I am telling something different than whatever I said. People use OC by EC minimum. I would say first we plot OC by EC. Just plot OC EC concentration. And if you are getting a good voltage, use the slope for this. What the slope means? What? Slope is what? For this EC concentration, you have that much OC concentration. For this EC concentration, you have that much OC concentration. That's the meaning of slope. Intercept means what? For zero OC, you have some zero EC, you have some organic carbon. It has to be secondary, right? Because wherever EC is coming, it is from some combustion. Whenever there is some combustion, EC and OC both. But variety of natural processes or secondary organic aerosol formation, etc., they don't produce EC. For zero EC, you can have organic carbon. That is secondary organic. And then same thing if you are doing WOC, OC. Here you see I put the intercept here. Normally plotted or normally plotted. Here can we have positive intercept? In some cases can we have positive intercept? लॉजिक वाला हो सकता है, बताओ ऐसे नो हाँ करके कर. Is it possible to have positive intercept? क्यों नहीं? और अभी तक एक ही होता जीरो ओसी. अगर ओसी जीरो हो गया तो ओसी कहां से लेकर आया? और ओसी इज द फ्रैक्शन ऑफ ओसी. जब ओसी ही नहीं है ओसी आ रहा है तो अभी जो क्रॉस वैलिडेशन की बात कर रहे थे, ये तुमने ओसी इससे अलग तरीके से मिल दिया है, ओसी अलग तरीके से. Now you are quoting, कहीं पे तुम दिखा रहे हो हमारे सैंपल में OC you are reporting 10 and W OC 15, तो मान लो कि ये को रिटर्न करा था, ये मतलब इस OC का मतलब, तो that's again phosphate, it has to be less than this, or usually it is having good correlation also, that slope, water soluble or aqueous SOC is usually representative of secondary organic aerosol. So by the ratio means whatever slope you are getting, say 0.5, 0.6, we can say that about 50 or 60% is secondary in this particular optical. So I hope you got the meaning of slope and intercept. इस शर्मा कैलिब्रेशन में बात की थी. See, just don't plot. You have to understand. If you are plotting something, you are getting some intercept and slope. You have to explain that. Now, OC/EC ratio, this is again good way not the best. But if you are getting lower ratio, consider it from fossil fuel sources, and if it is from biomass, means the fixed ratio, that it can be from biomass or you can have or can be from secondary. In both the cases, you will have high ratio. Another important thing is OC and OM. OC means organic carbon. OM means organic matter. Difference on those carbon. Say glucose. Glucose हम मेजर करें और कार्बन मेजर करें तो वो भी C6 में. We are not worrying about 12 H carbon OC. But when we convert it to OM, we have to consider it. Where it is important when you are doing mass balance. The filter का blank filter, loaded filter, from difference you got the mass divided by the volume, you got the mass concentration. Now you are building a different species. Then telling that how much is contributing to the mass. OM is contributing to the mass, not OC. So we have to convert. But we don't know whether it is glucose or pentopyrene. In this case, if you calculate the ratio is 2.5. In this case, if you calculate ratio is 1.06. 1.06 is more or less similar, right? One only. But 2.5. So here, high gram ला रहे हैं वहीं का वहीं. But we don't know. But we are not getting glucose or pentopyrene. We are getting OC. Usually, people take ratio from 1.6 to 2.2. Fresh aerosol considered 1.6. Aged aerosol more aging. क्या होता है aging? हाइड्रोजन हटाया, ऑक्सीजन आया. मास का डिफरेंस समझो. एक हाइड्रोजन हटाया, एक ऑक्सीजन हटा 1, ऐड हुआ 16. तो मास पता जाता है. तो 1.6 to 2.2. Depending on now some urban atmosphere, use 1.6. You are sitting in Arctic, Antarctic, transported aerosol, then you can use high ratio. Okay, then our instrumentation. This is most complex because so far you are saying organic carbon is organic carbon, can be anything. But if you want to identify what is organic carbon, there are thousands of species. So you don't have to measure all. It depends on your interest. Say if you have to identify certain thing, then you go for it. Otherwise, it is not required. So what are things here? So this is total. You see, out of that, this part is water soluble carbon. This part is solvent extractable. I have not written the solvent. Solvent extractable. Left hand side, this water is written, but other side it can be normal hexane, it can be methanol, it can be hexane. Variety of things can be there, depending on what kind of compounds you are looking for. Then certain fraction is common. That means it is mixed by both, by water also, by solvent. So this is the fraction. And now if you go further, that what are these? So you have humic like substances. Then polycarboxylic acid, different compound like polyols, polyethers, monomer dicarboxylic acid, etc. They are part of fluidity. Solvent extractable, if you see, they have done many, still this much is unidentified. That is what I was saying. Organic is very complex. What they could identify is sugars, organic acid like dicarboxylic acid, alcoholic acid, etc. fatty alcohol, phthalates, PHs, alkanes, propanes, etc. In our lab, we tried up to levoglucose, this part, and this part. Remaining, I have not tried for you. But it depends what you are looking for. Okay? So these things are the details of that. Fast. ये मेरे पेपर है. Scatter plot, I use 3 places. Now I want to infer. There is the slope and intercept. What information can be drawn? Now I am randomly going to ask one by one. Explain. Okay. WCVOC. Ah. What do you understand with this part? Here is the plot. We were talking about that. Slope is 0.45, intercept is 0.16. ये करेंगे बताने में खाना उतना ही लेट मिलेगा ऑब्वियसली. Okay. So slope is 0.45. What does it mean? In terms of, if we say that how much is secondary. Can you say something? Can't say. Possible. Ballpark.
Secondary carbon maybe
The first of all तो सर इसमें कोरिलेशन नहीं होंगे दोनों के बीच में R square.
Slope is 0.45.
कोरिलेशन की बात कर रहा हूँ. दोनों एडिशंस के अगर हम कोरिलेशन देखें तो परफेक्टली मैच नहीं हो रहा है. 0.73 बस नहीं है. 73%
24 correlation for real samples. You don't expect यहाँ पे हम लोग कैलकुलेशन नहीं कर रहे हैं कि 0.99 लेंगे. For real samples, it is quite a good correlation. अभी बताओ. On the slope, what do you infer? %, you can say. If now you say that you are showing intercept 0.16, in principle it should be 0 or it should be negative. But if you see the value here versus 0.16, it will become even better. Suppose if it was 2, then that was something. ठीक, अभी आते हैं R square is 0.5 here. Not very good, but कोई की तरफ से और बोल रही है One point six is go and 3 is intercept. There is more secondary carbon and slope is telling that faucet to derive aerosols are probably the sources of carbon of the air. अब यहाँ पे डिफर कर जो सेकेंडरी वाला पार्ट है वो दिस इज ऑल फ्रेंडली जो इंटरसेप्ट से आ रहा है और जो स्लोप वाला पार्ट है दैट इज टेलिंग दैट फ्रॉम वेयर पॉसिबल वाला पार्ट अमोनियम हमने कुछ बात की थी अमोनियम इज 18 सल्फेट इज समथिंग so you expect some slope if it is pure ammonium sulfate so from slope you can say whether ammonium and sulfate is existing in the form of ammonium sulfate or there are some other salts also here. Okay, so just take the mass of sulfate, ammonium whole twice. Okay, ammonium sulfate means ammonium whole twice SO4. So ammonium became 36, 98. The ratio if you see, it is 2.9 or something. How much is there? 3.2. That means sulfate is more than ammonium. That means you have some extra sulfate which is not balanced by ammonium. That means some other cations are also reacting with sulfate. So these are the things which we can infer simply by this kind of part. The starting, and then you more the churning you do, more the butter will escape. Okay. So overall, if you do the analysis and interpretation using your mind, even people may have better facilities than you can do better science. Better science doesn't mean that the people who have very good facilities they only can do. Also, some people write the paper on say chlorine only. केवल एक एलिमेंट में पूरा पेपर लिखते हैं तो पूरा फोकस इज ऑन so whatever data you are first to make sure that your data quality is perfect if your data quality is not perfect don't report don't try to publish for the sake of publishing once you are sure that data quality is good but it is not making sense then you use your mind you try to split the things in different ways trying to get more out of it and then extract. So with this, I'll be stopping this note, try to push boundaries and make more and more known. Unknown is very vast. This question, I am sure you will not ask. Okay. Hay question कोई? आला.
For your insightful presentation, we are truly grateful. Please, all of you gather back by sharp 2 p.m. Today, in addition to the instrument demonstration and hands-on training, there is an experiment demonstration by VRC team on how to achieve a steady state concentration. So please be punctual. And participants, please carry your coupons. And TADA form should be given to Vaishali at the registration desk.
स्टॉप पे जाना तिथं आता स्टॉप